So, as you guys can see on top, we're the Hutzler Yang group. Probably your favorite, maybe. I don't know. It's time to get awake a little bit. So, to start this off, my name is Desiree Nava. I am an oncoming senior at Santa Ana High School. And a fun fact about me is that I'm the oldest of 9 children. 9. Which also helps with my listening skills.
Hello, my name is Justin Guinea, and I'm a rising junior at Carson High School. And a fun fact about me is I love building Legos.
Hello, I'm Edgar Bravo. I'm also an incoming senior at Santa Ana High School. And one fun fact about me is as much as I love STEM and science, I also love music and playing instruments equally as much.
Hello, my name is Noah Hernandez. I go to Garfield High School and I am a rising senior. Fun fact about me is I play football.
And my name is Andrea Avalos. I'm also a rising senior at Garfield, and a fun fact about me is that I'm in musical theater at school, and I recently played The Witch in Into the Woods.
Well, the goal for our group was to have an Arduino board measure the audio waves of a cryogenic fridge, which is essentially just a super cold refrigerator. Quick question, who knows how cold, or do you know how cold one of these refrigerators can get? Any guesses?
Fahrenheit.
Yeah, Fahrenheit. Should have specified.
Negative 200. Negative 200?
No, it's pretty warm though. You're starting to simmer. Anyone else? Mike? Getting colder. Right there. Any more guesses? Well, wait, someone had a guess? Huh?
Negative 800.
You went from simmering to overboiled. There is no water left. But cryogenic refrigerator can get to negative 472.27 degrees Fahrenheit of temperature. And now I'm gonna hand it off to my good buddy Noah.
And with this goal, there's always a problem. The problem with this is the lab's cryogenic refrigerator. As Joseph said, it is a very cold refrigerator and is only at its peak temperature every half of a second, which means that it is hard to measure the data. So by implementing our technology, as the light turns on, which means that it's the coldest point, we will measure the molecules because the data will be accurate and precise at that single moment.
Alrighty, so I'll translate it for our folks who speak Spanish. En este programa nuestra meta de nosotros es que nosotros necesitamos codificar una placa de circuito Arduino 1 para medir ondas de audio de un sistema de procesamiento criogénico en un laboratorio de pruebas moleculares para tomar datos experimentales de forma sincrónica y generar una señal de sincronización digital. ¿Dije algo que alguien entendió? No, so we can keep going.
Alright, and some of the materials we use, which is an Arduino board. The Arduino board is the heart of our project. It is a small computer that allows for the creation of all of our designs. It consists of both hardware, which is a programmable circuit board, and software. You write code on a computer using the Arduino IDE, which we'll explain later, then upload it to the board via a USB cable. The board reads inputs and turns them into outputs based on the code. Next, we use an adapter cable that connects our Arduino to the computer. It's like charging an electric car with its charging port. We also use laptops, which are the main source of power and code for the Arduino. Additionally, we also use jumper wires, which are for making all of our connections from the Arduino to the breadboard. Later on, my groupmate Edgar will explain more on breadboards. Also, we used an LED, which is just a small light bulb, in which we plug into the breadboard in order to emit light when given energy. In other words, it's like a visual representation which shows when the light bulb receives power or signal. Next was a resistor, which stabilizes the power supply on the breadboard. We use resistors because when the energy from the computer flows into the breadboard, it contains a bit too much for the LED to handle. So when we apply the resistor, it stabilizes the power into a lower voltage in which the LED can process. We also used a certain software called Arduino IDE. This is our main coding language we use. It is a software like C++ and Python in which we type code into the Arduino. This code then performs the actions on our breadboard. We also use an oscilloscope. The oscilloscope displays our sound waves from our mic into graphs, which is useful because we can accurately measure the waves, which is crucial for our project. And
Moving on, we have our last material, the breadboard. Here is where we can make all of our external connections, which is like charging a phone on an extension cord.
Edgar, I think you have the wrong breadboard.
Oops. I know some of you guys imagined an actual piece of bread when we said a breadboard. This is not what we need.
Give us a minute to swallow that down.
Alright, a breadboard is this. This is where we make all of our electrical connections, and most importantly, it's reusable. Unlike many toys and electronics that only have a single circuit, which is not really usable in other projects. Not this.
And now we're going to take a look at what our progress looked like with a drum roll, please. Week 1, which was just getting an intro to the Arduino. And with this goal for week 1, all we had to do was get an onboard light for the LED to start blinking. You can see that in the video here. You can kind of see a little example of the Arduino blinking. And to get that happen, we have our good friend Arduino IDE to help us. And this is what Arduino IDE usually looks like when you're making your code. Now, up there where it says pin mode or line 6, it's essentially that line is telling what the Arduino what we're using, which is the onboard LED. And then the next line of code is to turn it on, make the light go on, or set it to high. And then the next line of code is a delay of 1,000 milliseconds, which after those milliseconds, the Arduino will turn the light off or set it to low. And then lastly, we have our void loop, which essentially just tells the Arduino to repeat this line of code over and over again, forever. And I would like to hand it off to Nick.
Alrighty, so did we lose anyone with that? Maybe coding a little bit difficult? So for our second week, we had to connect our Arduino to the computer so that we were allowed to turn on an LED light. With that, on this picture, you are able to see how I did it. I had to do a lot of coding, and as Joseph explained, it's really difficult. Has anyone here tried to learn a different language? Probably Spanish is not your first language. English isn't your first language. That's exactly how coding is. Coding is learning a whole different other language. I struggled a lot. So besides that, we can focus on the actual project. With the Arduino, I connected my Arduino to the computer, and the coding sent a message to my Arduino so that it knew exactly what to do. I connected wires from my Arduino onto the breadboard, which gave it electricity so that my LED light can turn on, which also allowed us to continue on to our third week. So I handed over to Andrea. She can talk more about it.
Like this. Okay, so for week 3, we focused on using the mic and connecting our circuits to the oscilloscope. So unlike usual mics that you probably see, we had to use an electronical mic. And on the left side where it says out, GND, and VCC, those 3 prongs are how we got power from the laptop to the microphone. So, starting with VCC, which is the supply voltage, the power comes in and it goes through GND, which stands for ground. And the ground is the reference safety point for all signals. Then from there, it passes to out, which, as you can probably guess, is the output voltage. That blue square there with the cross and the plus is called the potentiometer, which is just a big fancy word for the part that adjusts how sensitive the mic is. If you turn the cross all the way to the left, the mic picks up less sound. And if you turn it all the way to the right, it picks up more sound. If you look at the top and bottom left corners, if those 2 lights are on, that means the mic is picking up every sound. If the top one is off, that means it's only picking up certain amounts of sound. Now here's some pictures of our circuits connected to the oscilloscopes. So as you can see, on the oscilloscope there's cables on the table. And the black wire is connected to the green wire. So all the power that's flowing through that circuit is going out through the green wire and through the yellow wire. And it shows up on the oscilloscope as a graph. So in this video, you should be able to see the sound display on the graph. So you can see that, let me pause it at a good moment here. So you can see that all those lines go up when it's picking up sound and picking up high frequencies. This diagram in the middle here, labeled energy flow, is to show how the power flows throughout this entire circuit and setup. So from the laptop, which is our main power source, it goes to the Arduino, which goes to the breadboard. And the breadboard is where you have the meat and potatoes. It's where you have your wire set up. So following the lightning bolts from left to right, the power goes through the first jumper cable, then to the resistor, then it lights up the LED. And on to week 4 and 5.
Moving on, with all that work, we then look at connecting the Arduino to the microphone. For a week 5 and 4 milestone, we tried to sync the microphone to the cryogenic fridge, which again is a really cool fridge. And so, the way we know that the microphone is actually being read by the Arduino is using an LED. The LED turns on whenever the microphone sends an electrical signal. So basically, we control the LED with our voice, which allows us to move on to our week 5, where we actually try to sync that to our cryogenic fridge. Again, it's a really cool fridge. And here we have example.
Alright, so while Edgar plugs all of that in so we can actually show you guys, we have to stay really, really quiet so it can actually work. So with my fingers, I'll go 3, 2, 1. By the time I get to 1, we're all just gonna clap our hands together. Try to do it at the same time so it can actually work. Ready? Excellent sound. So for our final week, we finally finished. All that work is paying off. We finally got to stay here and actually go to the lab. So before I continue, does anyone want to take a guess on what that is? A little hint, it's not actually a minion. It looks like Bob, but it's not. No, it's not. Any other guess? Come on, don't be shy. No. It's actually the cryogenic refrigerator. So I'll hand it over to Andrea so she can actually tell us more about it.
Right, so the first 5 weeks was actually building the circuit, and the final week was when we actually got to test it. So what we did was this past Wednesday, we went to the Hutzler lab, and we took our circuits with us, and we put it right underneath his cool baseball hat. I don't know if you can see that blue light here, but there's our circuit. So we put the mic right underneath of the hat. And in this next video, you're gonna see how it responds. Pay attention to how it changes. Right, so what did y'all notice in the video? Yeah. Do you notice how it's blinking? Exactly. So our hard work paid off, and the blue light actually responded to the rhythmic sounds of the machine. And this means that the machine is at its coldest. However long the light is on is however cold the machine stays on until it turns off again. And this is super important to the research in this lab because they need the coldest temperature to be able to measure the molecules correctly. And so now they have this signal that tells them, okay, we can measure it now. And it tells them how much time they have to run their experiments, which is really cool.
The use of Arduinos is endless. This is only one use of an Arduino. We've seen here at Caltech many, many times in different labs, like this one right here, where they connected a cockroach leg to this little machine right here. We also use a similar machine to shock our friend here, Joseph. And above it, right here, it's a little box where we actually were able to see how, here in our seismology lab, how they measure earthquake activity in our Caltech hall. And then over here, we have this mannequin head that's connected to all these little chips, which is similar to what we're doing, and many labs have actually done this over and over.
Okay, so we would like to start our acknowledgements by shouting out our mentors, Yushi Yang, Tashandra Giles Jones in the back, working the camera, and Nicholas R. Hutzler, also in the back in the corner. These mentors were holding our hand through these 6 weeks, and they have just been such a huge part of our success. And they've given us so much wisdom that we're going to carry on after this program is completed, and we're very grateful. We'd also like to give a huge thank you to the following people, which I'm going to name off. So a huge thank you to Mitch Aiken, the education coordinator. Sorry, if I got your job wrong. Okay. Victor Vescu, Blanca Hermosillo, which is Shauna's dog. Lizzie Vela, Monica Kohler, Dee Dunn and the Sams, Jose Lazande Ramirez, David Valero Calvo, Juan Renteria, Alana Pizarro, Diego Blanco, and Diane Pollock, who's actually in the room with us. And of course, we have to give the biggest thank you to our actual coordinator, Ms. Shauna Hermosillo. Thank you. Are there any questions? Yes. If the bottom light is off, then the top one won't even turn on. That means like the mic isn't getting power at all. Any other questions?
For the coding, did you guys have to memorize all those codes individually, or were you made it like copy and paste, or?
Oh, can I pass that to Edgar? Our coding expert.
You don't actually have to memorize it. Many people learn code, but actually forget it. That's why learning it here, we're able to see it once, and when we see it again, we're able to, oh, there it is. we memorize it over and over. But as long as we learn it once, we're able to learn it faster the second time.
Any other questions?
Why does the fridge constantly turns on and off instead of just being on?
The fridge it's not turning on and off. It's kind of like a lung. It's breathing. It's going in and out because it can only maintain that temperature for a certain amount of time. So that's why it's breathing. So like when you hold your breath, it takes in and then it lets out. So when it breathes in, that's when it gets cold. So that's when we have to know. And when it breathes out, we have to know to stop taking in data. Any further questions? Dan the man.
Why do you guys keep the microphone in the hat? It doesn't keep it in the hat or your microphone.
No,
Oh, both
it was just to.
That was swag. Nick actually suggested putting the mic super close so that it could pick up the most sound from the two. So it could like actually turn on. Because if you took it a further distance away, it wouldn't pick up as much sound since we had it at a certain sensitivity.
like someone's in the room talking with your mic.
Yeah, actually, that's a good question. So when we went to the lab, we had to wait for everybody to be silent so we could actually see it work. Because then it would just, the light would stay on the whole time because everybody was yapping. Any other questions? Yeah. Oh,
So I know he said that the fridge gets cold in like a split second. How are you guys accurate with the microphone to like pinpoint the coldest time, basically?
I don't actually really know that much about it, but I'd like to bring up our mentor, Nick.
Yeah, so the microphone was listening to the motor that drives the refrigerator, and so it made that rhythmic sound that you heard. And if you put a temperature sensor, which we didn't do as part of this, but we've done it before, if you put a cryogenic temperature sensor, you would see that it was doing this synchronously with that sound. And that's because where the refrigerator is in the motor cycle changes the temperature. So the sound and the temperature are synced up. And so you don't have to, measuring the temperature is hard at these very low temperatures, but measuring the sound is that you can do in the room with an Arduino. And so it's actually a much better option for precisely figuring out when the fridge is at its coldest temperature. That's a good question.
Mitch has a question.
We'd love to hear from each of you what your favorite part was of the whole experience in HSRC.
Your rose, your rose, your rose.
My favorite part was actually working with the Arduinos, since it's such a really cool project. You can make anything you want. The possibilities of Arduinos is endless. I actually was personally thinking of making my own Alexa because of this program.
So my favorite, I have two favorites. I was able to make friends here and be around people that wouldn't judge at all. And my second, was going to all these different types of labs. I was able to open my mind to bigger opportunities. I was able to see that it's not just medicine or police academy or becoming a lawyer. You know, some parents push us to become something that they want us to become. And here we were actually able to open our minds and see that we can become whoever we want to become, not just, we were able to see that we can become who we want to be and be happy and not be someone that other people want us to be.
My favorite part was collaborating while also working. It was a fun scale. We would walk to botanical gardens, but then we'd also come back and work. It was just a real college experience. It's nice.
My favorite part of the whole program was making memories and making friends all along the way and doing all the fun activities.
I have a lot of favorite parts about this program, but if I had to take it down to just one, I would also say collaboration, but also the challenges that this project presented to us, because we ran into some obstacles, but guess what? We worked as a team and we figured it out together, and we even formed stronger bonds because of it. Like, the challenges only made us tougher and closer friends. Yeah.